13.7, last section of chapter 13. It's been a long chapter. Trigonometry is a big, big topic in math, and it doesn't end here. This is the final section of our chapter, but there is so much more to trig that you are going to explore in future years. And this is just laying the groundwork, all those fundamentals that are important. So there are two important concepts that are on the screen right now. The first one is one that you probably look at and you say, we already know that actually. If y equals sine of x, then the inverse sine function is written as sine with a -1 up there, or arc sine of x. Two different ways of writing the same thing. Similarly, inverse cosine is just arc cosine, inverse tangent is just arc tan. Keep that inverse sine circled. So we know this. But there's one little distinction that I want to take this opportunity to point out to you. Notice that we're using a capital S for all these sine or inverse sine, or capital A for arc sine, arc cosine. What's the deal with these capital letters? And this is, I've seen it kind of both ways, but I'm going to explain it how our book explains it. That capital letter means our answer needs to be the principal value of the trig function in question. What does principal value mean? Well, let's get some context. Here's our unit circle. We've worked with it a ton this chapter. If I said, hey, the y-coordinate of some angle is 1/2, so the sine is 1/2, you might be tempted to say, oh, well, here it is. It's right here. It's 30 degrees. It's pi over 6. But there's a second answer as well, right? Because the y-coordinate there is 1/2 at 150 degrees at 5 pi over 6. So which one of these is the correct answer? Well, they're kind of both correct, but one of them is defined as the principal value. Because in math, it's really good when we have a problem to get one answer. It eliminates ambiguity. Here's kind of how I think of it. I don't know if this will make sense. I'll try to draw it out. Let's say you have two engineers on two different sides of a lake, and they have a great idea. They say, we're going to build a bridge. We'll both start from each end. We'll do the math, and we'll meet in the middle. Well, if you can solve a problem and get two right answers, if engineer number 1 starts his bridge out and figures it needs to be that high, and engineer 2 gets a right answer, but a different right answer, and says, oh, my bridge needs to be this high, we're going to be in trouble when we try to make those two sides connect. So it's much better if there's only one official correct answer to these problems. And that's why we have principal values, so that the bridge will in fact connect, so that everyone working this problem will get the same answer. So here's what we have going on. It says if we're doing any kind of inverse sine, inverse cosine, inverse tangent, we have predefined answers to where, predefined regions, I should say, to where the answer will come from. For sine of x, and these are all written in radians, notice, your answer will come from -pi/2 to +pi/2. This region is where our answers will come from. The example I put up there in that purple circle of oh, sine is 1/2, and we said it could be 30, it could be 150. Based on this, it would have to be the answer in the first quadrant. It would have to be, in radians, pi/6, because this is the only valid region to pull an answer from if we're looking for the principal value of that inverse sine function. Now, the reason, if you're wondering why it was this half of the circle, we want half of the circle so that we get each answer once, and we need some where sine is negative and some where sine is positive, and down and up. And so mathematicians said, well, let's just start at 0 and say our answer can be -pi/2 to +pi/2, just that half the circle. Cosine, we can't use that same half the circle, and here's why. If I said, oh, the x coordinate is let's say root 2/2, positive, you could say, oh, it's right there, but I could say, oh, it's right here, and we'd both kind of be correct. Both of those have a positive x coordinate of root 2 over 2. So instead, for cosine, the region in question is 0 to pi. 0 to pi, anytime we do inverse cosine with that capital C, looking for the principal value, our answer has to be the version between 0 and pi. Now tangent, if you remember, tangent is positive in quadrants 1 and 3, negative in quadrants 2 and 4. And so right here, what do we do? Because we want one positive region, one negative region. We're actually just going to copy the exact same region as sine. We're going to say negative pi over 2 to positive pi over 2. And that will be the region for our inverse tans. Okay. This is also the reason, before we look at problems, this is the reason on your calculator, we've had this discussion, why does inverse sine of 1/2, why does it say 30 degrees instead of that other very valid answer of 150 degrees? That's because your calculator is programmed to only give you the principal value. It's programmed to always give that official correct answer. And sometimes in previous problems, we've had to say, wait, but we know better. We can see from the picture, it's probably the 150. Your calculator will always give you that principal value. So we don't have a ton of problems to look at, actually, just 4. But here's how we're going to work these. We're going to keep these principal regions in mind. We're going to think of our unit circle, and we're going to work out these inverse trig functions. Arc cosine of root 3 over 2. It's saying, where is the cosine value root 3 over 2? Where's the x coordinate root 3 over 2? Now, if you remember, that's from a 30, 60, 90 triangle, and we need the x to be the long side. So it's going to be one of these two. But which one? This is cosine. If you look above, our cosine region is that top half from 0 to pi. So we know we must be dealing with this point right here. It's 30 degrees. What is that in radians? Pi over 6. We got to start becoming more familiar with radians. We can check this, actually. I'm going to show you. I'm going to go to mode, and I'm actually going to change this to radian value. And I'm going to say, what is inverse cosine of root 3 over 2? And it says 0.52, great. I don't know what that is, but I can always say, wait, hold on, does that match the answer I know? Is that pi over 6? Yes, it is. I know I got this problem right. Moving on. What is sine of inverse sine of 1/2? So now we're going to start seeing some doubles. Well, I know that sine is the y coordinate, so if it's 1/2, it's here or here. But I know it's probably in that first quadrant because if you remember that sine negative pi over 2 to positive pi over 2, it's got to be this pi over 6. Again, the y coordinate is 1/2, so pi over 6. So really, this is sine of pi over 6. So what's the y coordinate there? Well, we just kind of found it. It's 1/2. And we probably could have done this one just by saying sine, inverse sine, 1/2. Just showing you the long way around there. All right, how about down here? Sine of arctan of root 3 over 3. Now, we don't know tans as well, I know. And we don't know radians as well, but we're still going to be able to solve this. Arctan, if you remember, tangent is positive here and here. And tangent is root 3 over 3 in these two places. So which one should we use? Well, that tangent was that right-hand side. Oops. That right-hand side of the unit circle, so we have to use that. So what is sine of that? Again, pi over 6. It won't always be pi over 6, but the first 3 examples I chose were all like this. Sine of pi over 6 is the y coordinate. Should just be 1/2. And again, we can check this in a calculator. Sine of inverse tan of root 3 over 3.51 half. All right, this is most of what you're going to be doing, using your knowledge of the unit circle to figure out in those predefined half circles, where is our answer? Now, occasionally though, your book will throw you one like this, 5/6. I don't remember that anywhere on my unit circle. I don't. So if you see a value that's not like root 3 over 2 or 1/2 or root 3 over 3, if you see something like this, we're just gonna plug it in. Cotangent, I don't have a button for that, but remember that's 1 over tangent of inverse sine of 5/6, 0.6633. It's not an exact pi value that we know of, so 0.6633, because we didn't recognize 5/6 on our unit circle. This section is almost completely your knowledge of the unit circle, saying where does sine equal root 3 over 2? Oh, that's up here at pi over 3, but it might be over here at 2 pi over 3. But no, it's got to be this one because of my half circle of sine on that right-hand side. Where is cosine? Nope, I lied. Where is sine -1/2? Well, it's either here or on the other side, down 30 degrees. So let me work that one out really quickly for you. What is inverse sine of -1/2? It could be here or here, but it definitely needs to be on that right side because of our predefined official answers. Has to be here. What is that angle? You might be tempted to say 11 pi over 6 if you're looking at your unit circle in front of you. But remember, our answer needs to be between negative pi over 2 and positive pi over 2. So what radian angle is in between those? How about just going down 1 pi over 6? This is negative pi over 6. Because we just went down pi over 6. That'll be my answer to inverse sine of -1/2. We can check it. Inverse sine -1/2. And is that negative pi over 6? Because that's what I said it was. Oh, is that sine of negative pi over 6? Excuse me. -1/2. So we know we did it correctly. So this section is all about your knowledge of the unit circle and your knowledge of those half circles, those official correct answers for you to pick the correct one. Because as we've seen on the circle, each of those cosine values, those sine values, those tan values do have two kind of correct answers. We want the official one. So 13.7, we're wrapping up chapter 13 with just a section all about the unit circle. Look at your practice problems. Hopefully they make some sense. Ask me those questions, get that practice, and congratulations, because chapter 13 was a long one, but it's a really, really important one. And it's one of my favorites, honestly. I love trigonometry, so I'm hoping these videos help. I'm hoping it made some sense. If not, I'm sure I'll get those questions in class soon. But that is it for chapter 13.